Hey everybody, 6th hour, super sub. I'm not sure if it's going to be Miss Gepke or not today, so that's why I'm making the video just in case. But here we go with 8.4 notes. So super sub, if you could please hand out 8.4 notes. We are going to do things a little differently, when don't we, for this class for 8.4, okay? So when you get these, you're going to be like, how come you're not using the same thing? How come I can't see the problems? Don't worry. Like I'm still going to, have the same examples. I'm just not going to do the fancy counting graph thingy, okay? So when you get your paper, you're going to notice that question number 1 looks like that, and it has, I don't know, it's got like a little graph over here, right? And then it's got a big old table, not just your normal 5 dots. Oh, no, no, no. Let's count that. 1, 2, 3, 4, 5, 6, 7. And there's like, no way, Blanchard. Do we have to plug it in 7 times to figure out the graph? And the answer is no. 8.4 notes, and then in parentheses, we're going to put modified. Ooh, we're breaking the law. We are breaking the law on this one. I hope you're ready for this. Here we go with this. Okay, so if you saw this and you're like, hey, I remember that, that's in standard form. And anytime there's standard form, you're supposed to do negative b over 2a first to find the axis of symmetry. So that would be negative 4 over 2 times 1. So that would be negative 4 divided by 2, which is negative 2. Then I'm going to plug it in. Like that. Yeah, and that's just all calculator. Like, you don't have to necessarily write all that stuff, do you? So what is that? That's 4 minus 8, so I'm at negative 4, minus 5, which is negative 9. So that means that the vertex is negative 2, negative 9. Now on the last quiz, then you just pick 2 points above that and 2 points below that, right? So I'm going to go to left, and then I'm going to go 9 down. Looky there. That's negative 9. And I'm going to put a dot right there. There's the vertex, okay? So I know since this A value is positive that it's going to open up, right? Okay, but now we are going to be graphing by something called the zeros. So now this is new. Now factor to find the zeros. I really don't, I like to call it the roots. The roots. Okay. So the roots are like called the solutions, okay? Now factor to find the roots. And you're like, factor what? Oh, factor red. Okay, how can you factor x squared plus 4x minus 5? Well, you guys should know that. What two numbers multiply to negative 5 and give you a 4? Did you say x plus 5 and x minus 1? So did I. Now you're like, how is this different? It's not. The only thing that I'm going to do now is instead of the y, I'm going to put that equal to 0, okay? Because I'm trying to find the roots, and the roots are the solutions, and the solutions are where this parabola crosses the x-axis, okay? And you better believe that we're going to find them. Okay, well, this is real easy. So then I'm going to say x plus 5 equals 0. So x equals negative 5. And squiggly line, x minus 1 equals 0. So x equals 1. That's new, but not really. Okay? Like you already have that algebra skill. It's just that you're like, hey, we've never set, like when we factor, we've never ever set that equal to 0 before. And I'm like, yeah, big deal. No big deal. Okay, so now I'm going to go 5 left, so I'm at 2, so there's 3, 4, 5. And since it's a root, there's the dot. And now I'm going to go 1 to the right. And since it's a root, I'm going to put a dot. And there is our 3-dot parabola. There is our 3-dot parabola. Whoa, whoa, whoa. It's hard to draw these lines. Okay, but you better believe if I were to draw this very straight, that's so bad. If I were to draw this very straight axis of symmetry, you better believe that those dots are symmetric from the axis of symmetry. What do you mean, Blanchard? 1, 2, 3 jumps. 1, 2, 3 jumps. How about that? It's always going to be that way, okay? So whenever you have 2 roots for your graph, it's just going to be symmetric like that, okay? Now, there are 3 types of cases, okay? And so example number 1 was what I consider to be the fun problem, okay? Because factoring is fun, right? Factor fun. Factor equals fun. And so that problem is now solved without having to plot, oh my goodness, 7 points. 7 points. That is crazy. Okay, so we're only going to do it, we're only going to plot 3 points. Here was the other one right there. There. How about that? Can we move on? Yes, yes we can. This is on YouTube, so you'll be able to rewatch it tonight. 3, 2, 1. Question number 2. Hey, let's try this baby out. Y equals x squared minus 2x plus 1. Ready? Okay, so step 1, do negative b over 2a. And go like this, negative negative 2 all over 2 times 1, which is 2 divided by 2, which is 1. And then plug that baby back in. So it's going to be 1 squared. I always like to put that in parentheses, minus 2 times 1 plus 1, right? I'm just plugging this value in right there and right there. You know what I'm saying? I'm just taking this baby and I'm just putting it right there and right there. Okay? That's all I did. Okay, so let's figure out that there vertex. 1 squared is 1, minus 2 is negative 1, plus 1 is what? It's 0. Well, that's cool. That means that the vertex is 1, comma 0. Okay? So I'm going to walk over to my little graph. I'm going to go 1 to the right, and I'm going to put a dot. Okay, and then what did I do next? Oh yeah, the next thing I did was I'm going to factor this baby. So I'm going to factor this, but instead of a y, I'm going to put it as a 0. So I'm going to say 0 equals x squared minus 2x plus 1. And I'd ask myself, what 2 numbers multiply to 1 and give me a negative 2? Did you say negative 1 and negative 1? Moi aussi. And that equals 0 because we're trying to find the roots. Oh my goodness, look what happens here. X minus 1 equals 0, so x equals 1, and then I'm going to draw a squiggly line, and you better believe I'm going to do it again. X minus 1 equals 0, so x equals 1. What? That means that's a special type of point. It's called a double root. Okay, and later on you're going to learn that double roots are going to bounce off of the point that you just found. Okay, so oh crud, okay, I'm just going to put a little red dot there because it's the same. And you're like, Blanchard, we're supposed to have 3 points. We're supposed to have 3 points to do this graph. Yeah, so I can't do the whole graphing thing this time, which means I have to, I'm sorry, the whole factoring thing, because it turned out to be the same exact point. Crud, I can't just, what? I have to find something symmetric. So you better believe I'm going to now pick 2 symmetric I sure hope I spelled that right. Points. Okay, in other words, pshoo, pshoo, we're back to the whole XY table, aren't we? And so we just found the vertex. The vertex was 1, 0. So now I'm going to pick 0, because that's one below it, and 2, because that's one above it. And I'm just going to plug in one of them. I'm going to do the same thing that I did here in green. So I'm just going to try 2. Why not? That'll be more fun. No, actually 0 would be a lot easier, wouldn't it? Let's do it. 0 squared minus 2 times 0 plus 1. And if I figure that baby out, I get 1. Well, you better believe, since this parabola is definitely symmetric, that that baby's going to be 1. Don't believe me? Go ahead and do it. It would be 4 minus 4 plus 1. Okay, so now I'm going to try to figure out where those points are. Oh yeah, 0 across, 1 up, 2 to the right, 1 up. And then I'm going to draw a very amazing, very awesome, you know it, parabola, just like that. Ooh, that one was much better. Okay, the reason that this one is special is because there was only one root. On problem number 1, there were 2 roots, okay? There were 2 roots on problem number 1, and it was nice and factorable, and everybody loved that. That graph is, oh, that just looks awesome. Okay. Now let's look at this one. Oh yeah, there was just one root. It was a double root, right? But it's still just one little point. So that just means I had to do 2 symmetric points, okay? And so that's cool. We graphed it. Case closed. It's a parabola opening up because the leading coefficient, fancy words, the leading coefficient is 1. Can we move on to example 3? That's right, you can pause it later on tonight. 3, 2, 1. Example number 3. Ooh, example number 3 is yet another special case. Okay, so they're getting all the special cases out of the way first. All right, I promise that there's that, like, not always are the special cases going to pop up, okay? All right, here we go. What do you do first? You do negative b over 2a. Here we go. So it's negative 2 over 2 times negative 1. So it's negative 2 over negative 2, which is 1. Then you take that there 1 and plug it in. You guys, some of you guys made this mistake on your quiz. That negative goes outside like that, okay? Just like that, okay? So that's what happens right there, okay? So if I crank out that, sorry, I was reading a text. This is really negative 1 plus 2 minus 3. So that answer is negative 2. So that means that the vertex is 1 to the right. And, oh, I said negative 2, but I didn't write it. Negative 2, which means 1 to the right and 2 down. Okay, so now we're going to be smart on this one. Hang on. We're going to go 1 to the right and 2 down. Make a dot right there. Okay, what direction is this parabola going to open? Is it going to open up or down? It's going to open down. Which means no roots. Okay, because the parabola is going to go like this, and it's going to go like this, so there's no zeros, there's no roots, okay? Up here where it crosses the x-axis, those are called the zeros or the solutions or the roots, aka the x-intercepts, right? Okay, so I have to, again, pick two symmetric points. Okay, so I have to pick two symmetric points. Well, crud. That means I still have to use that table, doesn't it? Pachoo, pachoo. So that's 1 and that's -2. So I'm going to go one smaller and one bigger. Okay, well, luckily for us, I'm plugging in 0. So it's going to be 0, which is really, it's -0. Really? No, that's 0 plus 0 minus 3. So that's -3 and that's -3 because it's symmetric. Wookie, wookie, wookie. So I'm going to go 0 across, but I'm going to go 3 down and make a dot. And I'm going to go 2 to the right, and I'm going to go 3 down. And then voila, meow, meow. That graph is done. So there were no roots, no solutions, okay? So if we look back at the very top of your paper, where it said 2 solutions, that was example number 1. Where it says 1 solution, that was example number 2. I know it's opened a different way, but it just had a double root. And then where it was no solution, that was example 3. Okay, let's see what we run into on the back of these notes. Hopefully not many of these, right? Because these aren't as fun. We like to factor, don't we? Let's see if we can do more of the factoring stuff and less of the boring plugging in points things. Okay, let's see if we can do number 4 a little quicker. I hope so. Don't you? Let's find out. Let's see, where are we at with this video? Hello? Hello? How come you're, hello? How come you're not showing up? Hello? I can't read that. How come I can't? Hey, show up. There it is. 17 minutes. I'm actually going to keep that up here. So we're on example 4, but I'm going to keep that up there so I can continue to watch it. Okay, so here we go. My computer on a Sunday night. Okay, so number 4 is y equals x squared minus 10x plus 16. Ooh, I like this one already. Okay, here we go. So it's going to be negative b over 2a. So negative 10 all over 2 times 1 equals 5. And then I'm going to plug that in. So it's going to be 25 minus 50 plus 16. 25 minus 50 is negative 25 plus 16 is negative 9. Okay, so that means the vertex is 5 to the right and 9 down. And you better believe on your graph that you have 1, 2, 3, 4, 5. And looky there, there's 9 down. So then I'm going to put my vertex right there. This baby's going to open up, so we're cool with that. But now, can we factor it? I sure hope so. 0 equals x squared minus 10x plus 16. You guys are all factoring pros. What two numbers multiply to give you 16 and give you a negative 10? Did you say x minus 8 and x minus 2? Well, they're equal to 0 because we're trying to find the x-intercepts or the roots, right? So that means that x equals 8 and 2. Okay, so I can go from here, that was 5, so 6, 7, 8, and make a dot. And then I can go here and make a dot. And you better believe if I were going to do the whole dotted line again, it's symmetric. Wookie, 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 right? Because, oh, looky there. There's my parabola. We figured out the zeros. That was so bad. I don't know why. Come on. Come on. There we go. And that parabola except for that little hiccup right there, and maybe just make the dot a little bigger. Oh, look, it worked. There's my parabola, and you better believe it's 1, 2, 3 jumps, 1, 2, 3 jumps. It's not always 3 jumps, but you know, that's just how it is with this problem. Can we move on? Of course we can, because we must. 3, 2, 1, click over. Okay, let's do number 5. So number 5 is y equals negative x squared plus 9. Oh, okay. So I'm going to call it, let's do it. So negative b over 2a. So it's 0 divided by negative 2, which is 0. Okay. So then I plug in 0, which means that the vertex is going to be 0 across, but 9 up. 0 across, but 9 up. So I'm going to go 9 up and make a dot. Okay, that's the vertex. Now you're like, I don't think we can factor that. Heck yeah, we can. Watch what I can do. I can make it negative and then x squared minus 9, and that's the difference of two perfect squares. We're going to replace that y with a 0, and so it's going to be 0 equals negative, and then it's going to be x plus 3 and x minus 3. That's right, all those factoring tricks are coming back right now. Hey, I'm going to divide by negative 1, so 0 divided by negative 1 is 0. And then if we're going to get really fancy here, we're just going to say x equals plus or minus 3. That means that they're both good answers. 1, 2, 3, and 1, 2, 3, dot, dot. I'm going to shoo, and I'm going to, dang it. And that guy is opening down, like it, you know, it took care of itself, even though we divided by negative 1. That's all good because the whole vertex thing took care of that, right? Way up there at 9 up. And then 3 left and 3 right again. Interesting. Can we do one more? Yes, we can. All right, here we go. I sure hope you've been following along. I think this is probably one of my best videos. That's not true. Okay, because it's Sunday night and I'm just trying to make this video and get it posted. Ready? 3, 2, 1. Alrighty. Number 6, another special case, kind of. Okay, let's do it. Negative b all over 2a equals 1. If I plug in 1, it'll be negative 3 times 1 squared plus 6 times 1. So it's negative 3 plus 6, which is 3. So that means that the vertex is going to be 1, comma 3, right? Hey, at least we aren't having to answer what's the domain, what's the range, okay? So, you know, keep that in mind. You're welcome. So I'm going to go 1 to the right and 3 up. 1, 2, 3. We already know that this this parabola is opening down because of that negative 3. So we know that there's going to be a couple intercepts, right? But now you're like, how do I factor that thing right there? Oh, yeah. There was one other trick that we learned, and it's not like difference of perfect squares. It was the GCF. Greatest common factor. Okay, so when all else fails, try to look for the GCF. I guess actually you should probably look for that first. So I'm going to take out a negative 3x, and then that's going to be what? X minus 2. Oh, I forgot to replace that y with the 0. Okay, here we go. Negative 3x equals 0. X equals 0. Squiggly line. X minus 2 equals 0. X equals 2. Well, yippee. So there's going to be a dot right here because that's one of the roots. And there's going to be a dot right there because that's one of the roots. And you know that this parabola opens down. Let's just make that dot just a, whoa, look at that. It went through the dot. Okay, now, wouldn't it be nice to know what type of parabola we're going to have if it's going to have two x-intercepts, or one x-intercept, you know, like a double root, or no x-intercepts? Wouldn't it be nice to know? Well, through the world of mathematics, I can show you how to determine, without even graphing, how many x-intercepts there will be. Okay, so your little chart, it says if d is greater than 0, then over here you're going to write a 2 solution. And then if d equals 0, then over here you're going to write 1 solution. And then if d is less than 0, then you're going to write 0 solution. Okay? And you're like, what does D stand for? D stands for discriminant. What does discriminant stand for? Did I spell it wrong? D-I-S-C-R-I-M-I-N-A-N-T. Oh yeah, okay. The discriminant is b squared minus 4ac. Okay, and remember, we're still looking at ax squared plus bx plus c problems, right, in standard form, thank goodness. And so let's try to do not all 6 of these examples, my goodness, no, but let's try to do 7, 9, 7, 8, and 9. Let's do 7, 8, and 9, okay? And I think I can do them right here. I hope so. Let's find out. Number 7. Okay, I'm going to do b squared minus 4ac. So it's going to be 5 squared minus 4. It's always a 4. And then a is 1. And then c is 4. So it's going to be 25 minus 16, which equals 9. And that is definitely greater than 0. So there are 2 solutions. Okay, you get that? This is easy. Number 8, let's try number 8 together. Number 8, okay, so I'm going to do b squared, got to put it in parentheses, minus 4, a is 1, c is 10, and that's it. Like, it's b squared minus 4ac. Okay, so that's going to be 9 minus 40. 9 minus 40. And that equals negative 31. Well, that is definitely less than 0. So it's 0 solutions. Huh, how about that? Okay, so I'm really just looking at this. All I'm doing is just comparing it to 0. By the way, that green 0 is looking so sweet right here. There we go. That one looked great. All right, and last but not least, let's do number 9. Okay, number 9. It is b squared minus 4ac. So it's going to be 10 squared minus 4 times 1 times 25. Oh, I can do that one. Here we go. That's 100 minus 100, which equals 0. So if it equals 0, then it's 1 solution. Well, yippee skippy. Okay, that's it. Those are our notes. That is the discriminant. And I taught it all in under 30 minutes. That is amazing. Way to go. Okay, so for your homework today, so Super Sub, if you could please hand out the homework paper. You guys today are doing 2 through 14 evens. So on the homework, you're not doing that many problems because we did a lot of notes, but you guys are doing 2 through 14 even. on the homework paper. Okay? I sure hope you have a great rest of your day. Work on your homework. Get going on it. Remember, you can always go to 24K Classroom. Like and subscribe, 24K Classroom. There's a 4 right there. On the YouTube, have you ever heard of that? And you can find this video. It'll be right there in the algebra section. Just look for the most recent video that I posted. And I say to you, good day.